Hello and welcome to the first video in a series on the M5 capscrew exercise. So the finished product that we'll be working towards will be this M5 capscrew here. You can see that it's a capscrew with a hex head, socket head in it. The actual screw thread itself will be creating using a cut sweep technique. So we'll be essentially extruding this triangular profile along a helical guide curve. So in this first video I'm just going to create the overall shape of the shank and the thread of the part. In a future video then we'll look at cutting the actual thread on it. Okay, so I'm going to create a sketch on the front plane here, and I'll create a revolved boss base from that sketch. So this has opened up a new sketch for me. Now I've copied already the dimensions from the PDF that you'll have got on the Moodle page. So I'm just going to paste those in just to have as a handy reference here. Now I'm going to do slightly differently to this sketch here. What I'm going to do is I'm just going to model this part of it here as a separate feature, and we'll add the head later as a second separate feature. So I'm going to model this amount of the part here. So I'm just going to create I've created a sketch. I'm just going to rough out the shape of that, not being too worried about the dimensions of it just yet. But I'll roughly want that to be level with the origin as well. So roughly set out the shape of it there. You'll see I've set my origin here, so that means that in the finished screw the origin will be along the center line of the screw. Now I also want to add in a center line here as well, because we're going to be creating a revolve feature out of this, and also because we want to dimension diameter dimensions as well. So if we dimension something relative to the center line, it'll put it in as a diameter dimension for us. Okay, so the overall length of this cap screw is going to be 10 millimeters long. The diameter, the major diameter, the nominal diameter of the screw is 5 millimeters, and then the minor diameter, or the diameter to the root of the thread here, is 4.02. So I'm going to dimension those now. So right mouse button and up to get your dimension tool, and I'm going to dimension the length of that there to be 10 millimeters. And that'll rescale everything for me there. The major diameter, so if I dimension from the top of it here to the center line, try that again. If I dimension from the top of that to the center line, I get the option to either put that in as a radius 2.92 or as a diameter 5.85. I'll change that to a 5.0. So that's the nominal external diameter of an M5 screw. It's nominally 5. In practice it might be a little bit less. It might be something more like 4.9. But we're going to leave that at the nominal 5 millimeters. Okay, so the other dimensions I want to put in then, I want to put in the minor diameter here of 4.02. That'll be from here to the center line again. And that's going to wind up being essentially the diameter to the root or the bottom of the thread. So that is going to be 4.02. Okay. Now, so the angular dimensions then, so this lead into the thread here, this is going to be an angle of 30 degrees. This chamfer on the end here, that is an angular dimension. Excuse me. So if I click on that and click again on the bottom line here, that's going to be an angular dimension of 45 degrees. And we're nearly there now. I've put a dimension on this chamfer here of 0.8 millimeters. Now that's basically the pitch of the pitch of the thread. So the distance from, say, the crest of one thread to the crest of the next thread is the pitch of 0.8. I've put the chamfer here to be 0.8 as well, so there would be exactly one thread length on that chamfer there. So I'm going to dimension that. I want a linear dimension from, let's say, from this point to this point, a linear dimension of 0.8. So you'll see it's context sensitive depending on where you move your mouse, what kind of a dimension you get, whether you get an aligned dimension, a linear dimension, etc. So I want this to be 0.8, 0.8, which is the, as I said, that's the pitch of the, or the length of one thread. And from here to where the head of the screw will be, I've put that as 1.6, which would be the length of two threads. Okay, and that is the, essentially that's the going to be the profile of our revolve. Just check everything is fully defined, and it is, so I'll accept those changes and revolve this around about our center line here. Now the revolve has automatically picked up that there's a center line in there, and it's revolved it through 360 degrees. So that is that's that more or less complete, and you could leave it at that. Now, just as an exercise for those of you who maybe have this done, if you want to optionally make this a little bit more involved, what you could do is you could set this up as a parametric model. So this, as I've drawn it here, this is an M5 thread. We could set this up in such a way using global variables like we've seen in previous exercises. We could set up a global variable for our major diameter here, maybe for the minor diameter, for the pitch, and for the length, so that this one model, we could use this to make an M5 or an M6 or an M8 by 20 mil, or an M6 by 15 millimeters length, or whatever parameters you want to put into that. So as I said, this is optional. You don't have to do this, but I'm going to do that now. So I'll go back in, right click on my sketch here in the feature tree, and go back into edit the sketch. So what I'll do is, essentially I want to create a set of global variables. So create a global variable for the major diameter, for example, here. So what I could do is I could go up to the tools menu and equations here and create a global variable that way. Or the other thing I could do is, once I have this dimension in here, if I go in and edit that dimension, I can say equals, let's call it D major, D-M-A-J. So this will allow me from this menu here to create a global variable called D major, and it'll set the initial value for D major equal to 5, which is what that dimension was there. So if I say equals D major, and click on this icon here for create global variable, it now will create a global variable called D major, which has a value of 5. Okay, and you'll see then that symbol there, this is a calculated variable, or a calculated value of 5. I'll do the same here now for my minor diameter, and I'll let that equal to D minor. Create a global variable 4.02. But we can come along and change those values later if we need to. Now I'm going to do the same thing here for that length of that chamfer there, and this is partly the reason why I set that value there equal to the pitch. So I'm going to change this here to equal, we'll just call it P for pitch. Create a global variable called P, which has a value at the moment of 0.8. For this one then, what I can do is I can put in an equation here and calculate that value of 1.6. So I can let that equal to my global variable P multiplied by 2. And that should then get calculated to 1.6. Yeah. And the last one then I want is the length of the overall screw, and that is going to be a new global variable again, equals capital L, and create a new global variable called L, which has an initial value of 10. Okay, so if I close out of that now, you should see we have these equations here, we have these variables, D major, D minor, P and L. We could come along and say manage those. If we wanted to make an M6, oops, you'll see that has changed the major diameter. Now it hasn't changed the minor diameter here yet, but we could do that. The minor diameter for an M6, we could look that up in a table, but that will be, I believe it's 4.77 would be the minor diameter there. And yeah, and that updates the model there. Okay, so I'll leave the video at that. I'll pause the video at that, and I'll come back with part 2. We'll maybe look at cutting the screw thread here.